Assalamu alaikum wa rahmatullahi wa barakatuhu. This is Dr. Najam, and I hope you all are fine in every respect. So, in the last couple of days, we have completed our radioactivity topic and nuclear physics. So, here today we will start past paper practice question sessions and paper 2 theory questions we will do. So, this is session number 1. So, kindly note down all the topical content that we will discuss here. Also, com- watch complete video till the end, and after that, you are requested to like, share this video with your other fellows to clear their concepts, and also subscribe the channel if you don't subscribe this yet. Okay, so let's start the session 1 of the topic radioactivity. So, in the question related about the radioactivity, examiner is asking emissions from a radioactive source pass through a hole in a lead screen and into a magnetic field as shown in figure. The experiment is carried out in vacuum. Now remember one thing, lead having symbol Pb. Lead symbol is Pb, atomic number 82, atomic mass 207. So this is an only element which can absorb radiations. Okay. So magnetic field is here. Magnetic field carrying two type of pole charges. One is your north, that is positive, south becomes negative. So first, examiner is asking over the 3 points. So basically, we know well about the charges that's a positive, negative, and neutral as per your radiations alpha, beta, and gamma. Okay, alpha, beta, and gamma. So alpha carrying positive charge, beta carrying negative charge, and gamma carrying zero charge. So over here, where we get these kind of radiations. So first of all, from the radioactive chamber at point B, we get gamma. We get gamma क्योंकि इस पे कोई चार्ज नहीं होता. Similarly, from the radioactive source at point A, this point we get alpha because alpha का rate slow होता है, तो वो इतने ज़्यादा deflect नहीं करता. Similarly, the gap beta 1, you will meet it at point C, right? Now, the radioactive source formation we have. So radiation detectors are placed at A, B, and C. That is your B, that's your C. So radiation detectors are placed at A, B, C. They give the following readings: 32 counts per minute for A, 5 counts per minute for B, and 3 counts per minute for C. The radioactive source is then completely removed, and then reading becomes 33 counts per minute for A and This is about three, and this is about two. So I can change the value as per our condition that we count as 52, and this is about 31. So this is about 21, and this is about uh, 39. Now from the data, given the position ABC, reduce the type of emission coming from the radioactive source and explain the reason why. As we know that we have detected the radiations, so how can we elaborate emission of alpha particle which are detected at point A having maximum ionization capability but so as I say that we can observe the presence of alpha, beta, and gamma radiations, and where we can detect as per their magnetic field range. So, as the question is asked about why we get radiations after the source removal, though this is background radiation, which are may present with the so many reasons, and the one of the most reason is that alpha and beta particles are present in the field, and after that these two particles are capable to ionize the other vapors and the other particles, so may generate background radiation. And the other cause for the background radiation is your cosmic radiation as well. So we get reading less than that of removal of the source. Okay, so whenever we place a source, so definitely count of radiation may increase, but once we remove the source, so except alpha particle, because alpha particles are capable to ionize more particles in the air, so we actually get heavy traces of alpha particles for a time being, rather than beta and rather than gamma, right? Now, in the next question, state the nature of gamma radiation. So we know well about the gamma radiation. Gamma radiations or gamma rays are electromagnetic radiations having very high frequency, having very high frequency and high energy. Now, a beam of alpha particles and beta particles passes in a vacuum between the poles of a strong magnet. ये बिल्कुल वैसे ही है जैसे भी हमने पिछले क्वेश्चन देखा. Compare the deflections of the paths of the two type of particles. So, if we compare the other radiation path, so अब यहाँ पे डायग्राम को ध्यान में रखो कि बीटा पार्टिकल का जो डिफ्लेक्शन रेशियो होता है वो ज्यादा होता है एज कम्पेयर टू अल्फा. दिस डायग्राम, then how can we write that? Alpha positive and beta negative deflected in opposite directions, right? Beta particles deflected more than alpha particles. ठीक है, तो आप यहाँ पे इसको मेंशन कर सकते हैं. एक और पॉइंट यहाँ पे मेंशन कर सकते हो अगर चाहो तो. The path of particles are curves or सर्कुलर. ठीक है, ये एडिशनल पॉइंट यहाँ मेंशन कर सकते हो. अब नीचे वही पूछ रहा है, a beam of beta particle passes in a vacuum through the electric field between a pair of oppositely charged metal plate. Describe the path of the particle. So describe the path of the beta particle. Same, these are the free fund marks. Curve path is observed, right? And deflection towards positively charged plate in opposite direction to the field, right? Now the nuclear equation as shown, this is the transmutation. What is exactly your X particle? This is your alpha particle, or you may write helium nuclei. Helium nuclei, you may write. Okay. Calculate the value of A and Z. Acha, one more thing. Whenever alpha particle is transmutated, so आपका जो भी एक्चुअल नंबर होगा उसके Z में से 2 कम होते हैं, 2 सब्ट्रैक्ट होता है, and from A 4 number is subtracted. So value of A with this polonium, that is yeah 206 plus 4, तो total कितना बना 210. And what about Z? That is 82 plus 2. This is your originally 84. So this is the way to elaborate the particular number of particles, right? Now another question, this is the same kind of that. State the nature of alpha particle. अब इसी तरह के क्वेश्चंस होते हैं इसमें. State the nature of alpha particle. So we may write alpha positive and alpha particle are positively charged particle and resemble to helium nuclei. अब अगर हीलियम न्यूक्लियाई है, that means ये मेंशन करना जरूरी है, resemble to helium nuclei with 2 protons and 2 neutrons. You may write like this as well, helium 2 and 4. ठीक है. Describe how an electric field between two charged plates could be used to determine whether the beam consists of alpha or beta. So, as I write above, alpha positive particles move towards negative plate and beta particles move towards positive plate, right? अब ये जो पॉइंट है ये पहले भी हमने लिखा था एंड they both reflected oppositely with curved path. Describe the path of the gamma rays do not deflect it. Okay, gamma is reflect नहीं करते. Now state what do you mean by the term isotope? Use the term proton number and nucleon number in your explanation. This is for the 3 marks question, and this is, you can say, a kind of a question, the bonus marks. So nucleon number. So first of all, you have to write the isotope definition. Atoms of the same element having same protons but different nucleon. You don't need to mention here neutrons. Different nucleon number, right? Because of change in number of neutrons due to instability of the nucleus of an atom. Got it? So this is the way how to solve questions. Now in this question, the counter of the radiation detector placed to the closed radioactive source gives a count rate of 1600 seconds per counts 1600 counts per second, and the half-life is 1 week. So after 1 week, what should be its count rate? So it's so easy. Does a 1 week half-life mean? You have to divide the actual half-life count rate with the 2. So we got 800 counts per second. Now, after the 3 week, what should be the count rate? After 3 week mean, it should be 1/4 of your respective count, which you have to calculate it at 1. That's your 800 by 1/4. So it would be 200 counts per second. Now, figure 1.1 shows the arrangement for an experiment to investigate the shielding radioactive sources. So sample containing 3 different radioactive rays. The sample 1 carrying gamma, sample 1 carrying gamma rays, sample 2 carrying beta, and sample 3 carrying alpha rays. Right? So here we can write gamma, beta, and alpha. Which type of radiation most ionizing? Obviously, alpha rays. So these are the questions. I hope you understand very well. So that's enough for today from my side. Kindly like, share, and subscribe the channel. This is Dr. Najam signing out. Assalamu alaikum wa rahmatullahi wa barakatuh.